Hi, everybody. We're going to work on section 5.3 today. And it's going to be very similar to 5.2, but we're going to actually be doing the opposite process. So in the previous section, we were given the z-score or the x value and asked to find the area, which is the same thing as finding the probability. So in this section, we're going to do the opposite or kind of work backwards. So instead of being given the z-score or the x value from the data, and then asked to find the area, we're going to be giving the area or the probability and then asked to find the z-score or the x value instead. So here's our first example. We're going to find the z-score that corresponds to a cumulative area of 0.3632. And then for part B, we're going to find the z-score that has 10.75% of the distribution's area to the right. Now, I'll show you both ways you can do this. So you can either use the table in your text like we did in the last section, or you can use technology. In either case, I still highly recommend drawing a picture first so that you can actually see the area that you're looking for, right? It's really important, I think, for us to be able to see that shaded region. We're still talking about normal distributions here, so we're still using those bell curves. So for all of chapter 5, pretty much, you want to just kind of think about bell curves here and that nice bell shape. So we can use that picture just to help us visualize what we're trying to find. So I'm going to do that in both of these examples. Now, I do have a couple notes here. So when you're using the table in the text, what we're going to end up doing is we're going to find the area in the body of the table first and then work backwards to the matching z-score. And one thing we do have to remember is that the area in the table is always given to the left of that mark, right? So when we use that table, the shading is always on the left. So we may need to tweak as we're finding our values like we had to do in the last section. When using technology, which is usually my preferred method, what we're going to do is press the second bars key. And then the function we're going to select this time is inv-norm. It basically stands for inverse norm. And inverse is an opposite operation. So that's why we're doing the opposite of what we did in the last chapter. So inverse, you can think of opposite. What we're going to do is we're going to enter the area, again, to the left of the mark. So the key thing here is when we're doing this process, you're always thinking the area to the left of whatever mark you're looking at, whether it's an x value or a z value. We tell our calculator the mean and the standard deviation, and then the relevant z-score, or later we'll see x value, will be returned to us. So when we're using the mean is 0 and the standard deviation is 1, then you're looking at z-scores. If your mean and standard deviation are anything different from that, then you'd have an x value. So remember that z-scores are always have a mean related to 0, or that distribution does, and a standard deviation of 1. So that's important to keep that distinction in mind. All right, so let's look at A. All right, so the first thing again I'm going to do here is I am going to draw a picture. So I'm just going to kind of make a quick bell curve. And I'm looking for the cumulative area 0.3632. Now again, we're finding z-scores. So your mean here is going to be at that 0 mark right in the middle. And then cumulative area always is area to the left. So if you see cumulative area, they mean the area is shaded on the left. So just keep in mind some basics from the curve from last time is that 0 here, I'm just going to kind of put it in lightly, you have 50% of your data on the left and 50% of your data on the right. So you have that 0.50 kind of as that cutoff mark in the middle for the area. So if I'm looking for the area of 0.3632, notice that's smaller than 50%. So my cutoff mark is going to be someplace to the left of that 0. So this cumulative area right here is about 0.3632. And we're trying to ask ourselves, okay, what is this z-score that would give us that cumulative area? That's what we're trying to find here is the z-score. But again, that mean in the center is going to be 50%. So if it's less than 50%, so this would be about 36%, that I know it's somewhere on the left of the mean. So I'm looking at some sort of negative z value here when I set up this picture. So even though I haven't found the answer yet, I actually have a lot of information already just based on the area. So I know I'm going to have some sort of negative z value. Now I'm going to do the calculator first, and then I'll show you the table. Okay. So here's my calculator screen. And again, you're going to hit that second button and then the vars key, just like we did in the last section. But this time you're not using normal CDF. You're going to use the next one down, which says inverse norm. And what you're going to do is, so I know it says tail here. The tail part is not applicable on a regular Ti-83 or 84 calculator, so I'm not going to worry about that piece. You don't need it, and I'll show you how to enter it. So you're going to enter your area. We always enter the area with the shading to the left. So here my shading is on the left, so it's already set up perfectly fine. So I just entered that 0.3632. And then I'm going to put a comma, and then I enter my mean, and then my standard deviation. So if I'm talking about z-scores, my mean is going to be 0, and my standard deviation is going to be 1. And then you can close the parentheses, or you can just hit enter, and you get a value of negative 0.349918. So there is our z-score, and we usually round to about 2 decimal places. So about negative 0.35 would be our answer here. All right, now let me show you what the table would look like. So that's the calculator piece. Again, that's my preferred method personally. I like it because I usually have my phone on me, so I have the app easily accessible. It's also nice too because it works really for any values, where sometimes your table is, restricted. It's already rounded for you and things like that. So it just gives you a little bit more flexibility. So your instructions are right here if you forget. So second vars, inverse norm, and then you enter the area, the mean, and the standard deviation. And remember, area is always in that decimal form, and it's always the area to the left of the mark. So here's the mark we're looking for, so you should enter the area to the left. So now we're going to use the table. So I'm going to go to that table. It's in the back of your book. It's table 4. So give me a second while I get that on the screen for you. All right, and again, the table always refers to the shading on the left. Now I'm on the negative z-value page because I know my z-value is going to be negative because the shading is less than 50%, less than 0.5. So I'm going to start here. But we're looking for the value 0.3632. So what you have, it's like a scavenger hunt here. So you have to kind of look in the body of the table for that value 0.3632. And so I can see my 3's down here. And I see it right there, 3632. So then you're going to move out left and above to see what it matches to. So 3632 matches to negative 0.3. And then if I scroll up, see if you guys can see this. Zoom on a little bit. So let's see, there's that 3632. So if I go to the left, it's negative 0.3. And then if I go up, I see it's 0.05. So that's the hundredths place value, and then there's the tenths place. So we get that same answer of negative 0.35 using that table. Now, if you can't find the exact value in the table, sometimes you'll have to estimate like in between. So that's why the table can be a little bit tough because not every single value is here. But a lot of them from the homework will be here. So at least some of them. So you can find them in your table this way. So remember, you're looking for the area, so the body of the table, and then you're working out to the z-score. All right, let's do the next one too. So the second problem asks for 10.75% in the area to the right. So the first thing I'm going to do is I'm just going to get that bell curve set up here. And we don't usually use percents in the table. So what you can do is change this to a decimal by moving your decimal point 2 spots to the left. So 0.1075. And again, this is the area on the right. So if I'm talking about z-scores, my mean is right here at 0. So again, we're looking for z-scores. So your mean is at 0 and your standard deviation is 1. I have 10% on the right. And again, this splits it in half. So you have 50% here and 50% here. So if I have 10% on the right, it's going to be way over here. So maybe somewhere like this. Okay. And this is going to be that 0.1075. So again, what we're looking for is we're asking ourselves, well, what is this point right here? Z would equal to what? That's our question. Okay. Now, again, you need to be careful because when you're using the calculator here or the table for inverse norm is a little bit different than the normal CDF on the calculator. It asks you for the area to the left. So even though I know the area to the right, I can find the area to the left by subtracting with 1. So if I do 1 minus 0.1075, then that would give me the area to the left of my point, which is actually what I need to use the table and to use the calculator for the inverse norm function here. All right, so let's do that subtraction real quick. And I have 0.8925. So you just want to be careful with this section when you're entering your data, even in the calculator this time, you have to enter the area to the left of the point that you want. So even though I know this area, I'm going to actually enter this side of the data so my calculator can find that value for me. All right, so I'm going to go to my calculator again here. I'm going to press second bars. And again, I'm looking at inverse norm, and I enter the area to the left of the point. So I'm going to use that 0.8925. Then I enter my mean, which is 0, and my standard deviation, which is 1. And it's always the same thing. Area to the left, mean, standard deviation. And let's see, I get that z is equal to 1.239933, etc. So usually round to 2 decimal places, so 1.24, right? Because this 9 is going to bump that 3 up. So that's how we do it on technology. See that a little bit better. There we go. And now I'll show you how to do it in the table. So again, you're welcome to use either one if you're doing it on the table. Now again, notice that we're on the right here. So if we're to the right side of 0, our z-score should be positive. So z-scores on this side are positive, z-scores on this side are negative. So I'm going to go to the positive side of the table for when I start searching. So here's my table. And again, it reminds us that the table always refers to the area on the left. So the value I'm looking for here is that 0.8925. So I'm just going to go through, and I do see it right in here, right? So there's that 8925. You guys see it? No, there you go. 8925. So if I go to the left, I see 1.2. And then if I go up, I see 0.04. So my z-score is going to be 1.24. Okay, so the same value we got using technology. Okay, so they're both good. Like I said, the only problem with the table is you always can't find every value. So sometimes you have to estimate or kind of go in between two values to get an approximation there. All right, let's do a couple with percentiles, and then we'll look at the x values. All right. I'm just going to get my numbers out here because I already have some of this done. Okay. So when we're doing a percentile, so we talked about percentiles a few lectures ago. You want to remember that the percentile, it gives the amount to the left or below. So P5 refers to the 5th percentile. So if I draw that picture, okay, and again, we're looking for z-scores. So when you think z-scores, think mean is 0 and standard deviation is 1. So that center is right at 0 here. This is the 5th percentile, which means that you have 5% of data to the left. So it's always in reference to the left. So think about 5%, that's very small, right? 5% in decimal form be 0.05. So this is the 50% mark. So you're way over here. So perhaps maybe up to right here. So this area is going to be 0.05. So again, percentile always is the area on the left. So this is 0.05. And again, you're looking for what is that z value. All right, so I'm going to use technology here again to start. So I'm going to press second bars. And then I use inverse norm. The area to the left is going to be 0.05. My mean is 0 z-scores, and my standard deviation is 1. And when I get that value, I get that z is about negative 0.164485. Now, this is one of those exceptions where we tend to actually round this cutoff value to 3 decimal places. So you'll see it like this, or sometimes you'll see it rounded to 2 decimal places like that, but this is one of those rare exceptions where we use this 0.05 cutoff a lot. On the lower end and on the upper end, it's a very common one, and we tend to round it to 3 decimal places. So you may see that in this case. So we're going to leave it at 3 decimal places there. All right. Now, if I want to use the table, so I'm going to do the table just one more time, and then I'm going to stick with technology for the last two. Okay. Again, notice that I'm on the left here. So z-scores to the left, let's say I didn't do this yet, would have to be negative, right? Because it's to the left of 0. So I'm going to look at the negative side of my chart, which is here. And I'm looking for that value of 0.05. So, all right, so you're going to notice here that I don't have the exact value of 0.05. So I go from let me see if I can scroll this up a little bit, 0.0495 to 0.0505. So what's happening is that 0.05 is lying right in between. So we can see that the first value is negative 1.6. So that part matches. And then if you go up here, the 0.0495 is at 0.05. And the 0.0505, which is a little too big, is at 0.04. So that's how you get that value right in between that 0.045. It kind of averages those two together. So here, if you were using 2 decimal places, again, your book answer would probably defer to the 0.05 one here and rounding up, but this one kind of occurs right in the middle. So you would average those together and do that negative 1.645 instead, kind of cut halfway in between those two values. So like I said, that's when the table gets a little bit tricky because not every value is always there. So if you're in between two values, then what you can do is, I guess, take the lower value and then go to a third decimal place and put a 5 to kind of cut that average. All right. So for the next one here, we're looking at the 50th percentile. So 50th percentile means that you have 50% of data to the left of that cutoff point. Now, 50% of your data is going to be right here at this mark. So you may know this answer already, right? It's on the chart, but let's say you forget and you're not sure. I'm going to just use technology for this one. So I can do second var's inverse norm. My area is 0.50 or 0.5. My mean is 0 and my standard deviation is 1. And you see you get the answer 0 here, which makes sense because I can see that the value is 0 right there on my chart already, right? That center is always at z equals 0. So our answer here is z, 0. And then for the last one, you're at the 90th percentile. So that means 90% of the data is to the left. And again, if you are unsure, you can always take that decimal point, move it 2 spots to the left. That's how you get the decimal version of 0.90. That's how I got the decimal version over here of 0.50. And I'm going to draw my picture. Now, if you're at 90% of the data to the left, then you're way over here on the right side, right? Because here's 50%, so you must be over here. So I'm looking at maybe something like this all shaded in. So this is 0.90, 50. And again, we're asking ourselves, what is this value right here? So using technology, I'm just going to do that inverse norm one last time. 0.9 or 0.90 for my area, mean of 0, standard deviation of 1. And I have that z is about 1.28155 and so on. So again, just rounding to 2 decimal places here, z would be about 1.28. And again, it makes sense that it's to the right, right? Because we're looking at a large percentile, so we know that z is positive. So I might answer 1.28 does make sense here, that it's positive. So that's how we can find those z-scores. In the next video, we'll look at how to find x values.